Hi, it's Gadget UK here again, back for part 2 of the A4000 repair here. There will be 3 parts because, as you'll see in this video, there's still quite a lot to do to this. It's taken a considerable amount of effort. So as we left things in the first part, there are a few issues with the audio still. A lot of recapping still needs to be done and some corrosion to be cleaned up. We needed to swap out the Super Buster. We had a couple of faulty memory modules. And it just needed a general sort of clean up and test, but there's quite a lot of work, and the real-time clock wasn't working either. Can you hear that rumbling? Let's turn it down a bit. Again, it's sounding very twangy. That zoom, zoom. So with the mouse port, I've solved that. That's just needed a thorough clean. The pins were actually having a bit of corrosion all up and down the sides of them. I'll show you if I just plug us back in. Now previously I'd have to wobble that mouse port all over the place, but you can see it's working. And the buttons are working as well. I've got no fast RAM in this just at the moment. Yeah, the other thing we're just going to have a quick look at is the clock, just to see if the battery back clock is detected. That says they're detected. So it's on there, I just need to just solder it on. The interesting thing is, I measured these up and I could have sworn I'd ordered exactly the right size. I'll stick the dimensions up top left of the part that fitted. It's a little bit smaller. This one here is the same length, I think, it's just like twice as wide, strangely. I'll get a little bit of flux on there to reflow it in a sec. I just want to get it on there. Let's just get a little bit of flux. I'll try not to get masses because it's just going to make such a mess. I think technically I should have waited for this cap to arrive before I decided to fit the electrolytics there. It would have been far easier. So let's just try and get a little bit of solder on this side. I'm at a weird angle here. There we go, that's the side. So I'll just inspect that and clean it up. I haven't finished messing around the audio section yet. We've still got the sound sounding a little bit odd at the beginning of June. The other thing is June, as I hopefully captured earlier, freezes, part way through. And I've tried a good, I don't know, 20 or so other games I've got on floppy here. Can't get hardly any of them to boot. They all sort of do weird things like freeze and get stuck with sound issues. They don't load. But I think that's the 060, because as soon as you put the hard disk on, as you can see, it boots and anything on the hard disk works. So it's not like there's a problem with the system. Now the problem I have got is there's no games. I can't believe someone's got this much stuff on here and all they've got on it is UFO. I mean, I can load that now. You'll see it works. It doesn't crash or anything like that, so I do think the problem I'm having with floppies is the fact this has got no 60 in it. Probably combined with the version of Kickstart that's on here. I'm not sure how you can get the intro up for this, but if we, I think if we just do this, then hopefully we should get some sound. Yeah, there you go. Does that sound normal? I don't know. Is there an intro on this? Let's just choose new game. Beginner. Oh, I haven't got a keyboard connected, so I can't start this, can I? So I think I found a bad connection on the real-time clock chip, but in the meantime, I think the next thing I'm going to do before I fix that wire is I've removed this piece of shield here. Off the back of there, I've removed the nuts. I'm now going to remove these sockets because it'll just help because I can measure. It's on the ESD mat here, by the way. I'll be able to measure from these points here, from the top side, very easily to the caps, just to check that those 2 caps are the right way around. I've got no idea how easy this is going to be. It's probably the first time, well, in a long while, I've had to remove these actually. But you've got quite large ground rails and things connected to these. Oh, the solder station's blocked itself. Might need to bring the iron in and touch this at the same time. Yeah, you can see the solder is coming off, but it's not going to be easy. They're a weird shape, these. Now the nozzle I've got is quite large, but nevertheless, it's going to struggle a bit. Yeah, just finishing these up here, it's easier, I've found, with the normal solder pump. Well, I think it is. Yeah, that's looking pretty free now. It's just this one, isn't it? I need to get in at a bit of an angle here at the side. I think most of the solder is free from that now, actually. Yeah, so I just heated and pulled a little to free them up. We'll just get rid of the excess solder here. Yeah, they're looking pretty clean. So I added a little bit of solder and used the desolder pump there to clean up that side. I'm just going to clean off around there, and then we'll just use the fiberglass pen actually. Because bear in mind, let's say the corrosion has kind of got to this bit. While we're here, we'll give some of these things a go as well, because we're right next to them. Yeah, I think that'll do. So we'll just give that a clean. You can see the difference that made to those little components there. Actually, let's just try and get right up there. I mean, I did already clean this area, but you know what? A little additional clean is not going to do any harm here. Yeah, that's looking a lot better. Something I will point out, these are not an exact fit. You've got to press and hold them. Bend the legs inwards a little bit. Yeah, and press and kind of hold it down so it's straight and it's flush, because they are not the exact size for this. But you can make it fit. I might need to adjust this in a minute because I'm not sure they're both straight. Yeah, I don't know if you can see this. Look how clean that bit is there. It's got muck or something on it. It's filthy. So hopefully this is going to go back together right. Can you see here it's raised a little bit? It's like these, if I can try and show you, they stand off. If you look at that there, you can see it clearer here. Yeah, it's just you know, obviously a piece of shield, but these stand further forward. Not only are the pins wider, that it stands further forward. You could argue that this white one just needs a little press that way as well to straighten it. There you go, those are pretty straight now. I need to stick a wire on the real-time clock next. It's this side of the crystal here, the right hand side of the crystal. It's not making a connection to one of the pins up here. So as you can see, I had to take the connectors off last night. The reason being is, if I just line these up, I don't know if you can see I've had to bend a little L into that prong there because it was going straight up, which meant that whilst it fit the profile of the you know, the solder points on the PCB, it was kind of sat, let me just show you, like that. Here's this one here, about a millimetre too far forward, which, as you saw, meant that this on this side here was kind of like pushed out like that. And it also meant that the screw mounts were not fitting in the PCB properly because of it. So yeah, I've had to modify these. The other thing is, can you see, if you look here, there's like a little bend in them here at the point, you know, so they come on, you know, inwards a little bit. Yeah, I'm not sure how well that's going to come across there. You know, it's bent in a little bit by a millimetre on each side. So, you know, I've had to do that as well. This one's bent right over there. What's happened to that? It doesn't want to be over there like that. This one, this side here, needs a bit more of a bend like that. You can see that one's not too bad. It needs a bit more of a bend on this side. But again, we've had to put this little L shape, you know, it's really difficult to bend that. But I think the profile is correct now, so I'll get those back on and we'll see if it fits the case properly. So when I was filming the bit where I was checking the polarity of the audio coupling caps, I pressed stop instead of record. So it's really annoying I didn't have the clip. But what I did is, you can see the audio coupling cap there. That's one channel. There's one on the other channel down there. 22 microfarad, 16 volt. That's the cap. C443, I think it says there. Yeah, I think the one's C433. So you've got your two audio coupling caps. The positive side should be nearest the output of the op amp, and the negative side should be connected to this resistor here. So if you measure from the audio connector, this is where it gets a bit difficult. You're measuring that resistor, that 1K resistor in between. But I think you can do it that way actually. We should measure 1K to the negative side of the cap, and that's exactly what I found on this board. So it looks like the cap markings on the silk screen are correct for this Rev B. It's really difficult to capture both of these things on camera at the same time. Hopefully you can see the meter, and if I measure, hang on, and if I measure the supply rails to this op amp here very carefully, you can see on that side we've got positive plus 12, that's about right, 11.63 volts. And on the other side, look at that, minus 10. Now we know we've got minus 12, a really healthy minus 12 coming out of the other side over there. So I am not clear as to what is going on here. I'm sure it should connect there. Or is it this side? No, I think it should connect to that side of that cap there actually. So we've got a wire or something here. It's doing that usual freeze at this point, but I think that's because it's an 060. Well, I'm not sure what to make of this. Just following the minus 12 volt rail, it comes up and goes to a resistor here. And if I, is that the right one? Yeah, measure across that, look at that, 80 ohms, right? R403 is the other rail, and that's 1 ohm. These should both be 1 ohm. So it would appear that resistor has turned into a larger resistor. It's changed from 1 ohm to 80 ohms. A minute ago it was over 115 ohms. So could it be as simple as that resistor? I've checked all the wires and things around it, I don't see a fault, but there's definitely something going on with that resistor, I think. So I think the next thing I'll do is remove that and measure it. I'll just double check it is the right one, R404, that's correct. So if I show you this page from the schematic here, can you see this? We've got R403 on the plus 12, that's the one that's okay. Minus 12, R404. You see that? 1, both 1 ohms. This one's measuring 80, this one's measuring 1. So that would explain it. That would entirely explain the issue, because the op amp is not swinging evenly. And by the time you've got some of the filtering and stuff, well, not really filtering, but the feedback and all that, it's going to sound really weird when one side is kind of pulled the other way. Maybe that's what it is. Maybe there's another issue as well. But yeah, I think we'll get the hot air onto this next and remove that resistor, see whether that's the issue. I'm not sure whether I've got any 1 ohm resistors in this size, so I might have to order one. And in fact, thinking about this, before I remove that, you know what I'm going to do? I'm just going to bridge it out. It's a 1 ohm resistor. It's the reason they've probably gone with 1 ohm is probably just to act as a fuse, more or less. I can't really imagine why 1 ohm would be beneficial there, other than you want it to burn out, you know, if something goes wrong. I don't know. I honestly don't know. It's so low. So yeah, let's just bridge it out. I can remove it with some hot air in a minute if we need to, but I mean I haven't got a replacement for it anyway. So let's just have a go, make sure I got the right one. Yeah, it's R404, isn't it? So if we just add a little bit of solder there to that side, a little bit of solder there to that side, it's driven me nuts. I've been checking all other connections around the Polar that might be affected. Some of the ones that run down the side I'll show you in a minute that I was concerned, could be related, but they're all controller related actually, which is a pleasant surprise. Well, it might not be because we've still got controller issues, but I think that's the ports, the connector, rather than anything else. So obviously you need to make sure you don't short this to anything else here. Last thing you want to do is feed -12 somewhere you didn't intend, but I can just measure on connectivity in a sec, just to be careful. Yeah, that's joined on, I think. Yeah, that's there. So let's just see if that sounds any better. That's the volume. It was the wind noise at the beginning that was missing. It was really distorted and crackled. No, that's still not right. So, we've still got a problem. Anyway, that is something else resolved, but it's not the answer. I'll just measure the voltages on the op amp again. So I think the next thing I'm going to do is swap out the ROMs for these this diagram pair here. You can see they're really nice actually. I got these off eBay. It was only about £6 or £7, which saved me the effort. Got a bent pin there. Saved me the effort of having to get the right chips and program it up. It's just convenience more than anything. So if we just get these out, it's not clear as to which one's the low. Well, and that's the low, isn't it? D0 to D15, D16 to D31. So yeah, let's try and get these out. Super difficult because there's not much room to manoeuvre in here. I would have preferred if these had been in the middle of the PCB just for convenience of removal. Everything gets in the way. If I play a test module, is that normal? Kind of sounds normal. I know, it's a mystery. I've got it on times 10 here, so you can ignore the voltage levels. They're like 10 times less. See that? That's a sinus wave, 440 Hz with a filter on. And if we look at the other channel, it's the same. I mean, my scope is showing 106 millivolts, but let's say it's on times 10. It's not accurate. 106 millivolts, it's jumping around a bit there, but they look the same. Now, I've zoomed in a little bit to look at the detail of those waves, and they're identical. Yeah, just zoom a little bit. Can you see that? So that's one channel, that's one side. Let's watch the other one. They look identical. It's like 0.96 volt there. Again, 0.9396 of a volt. They're identical. There's no difference. So let's try the triangle wave. Right, I need to change the time base here. Look at that. That's a nice triangle wave there. 0.96 volt again. Or 0.096 volt. Same again. The other side. They look identical. They look absolutely identical. So I see no differences between the left channel and the right channel. So I've took the battery off in order that I can measure some of the connectivity around here and have a bit of a clean up around here. But we need to get access to this cap as well, and it was kind of a bit inhibited, not much. Is that the other way around? I think it was that way around, wasn't it? So we'll swap out these other caps as well. So just use the hot air. So before I remove these caps, I'm just going to get a little bit of Captain tape over here. just to protect the side of that. I'm sure it'll be okay, but I don't want to risk it. There we go. Just come off, no damage. So I didn't catch this one on camera, but the pad came off with this one here. So it goes to a little wire there by the looks of things. So I can put a piece of kynar through there and solder onto that. It should be okay. And the one on this side, can you see? It's at a weird angle. Yeah, they're hanging on, these ones here. In fact, that one's already got a piece of kynar. I can see it there. So I've got some flux on there. Just heat gently with some desolder braid to clean those up. The other thing I'm going to do while I'm here is just inspect and clean up a little bit around here, because it just looks really dirty. Can you see? That looks like that's being replaced or reflowed, but we've still got a problem with the real-time clock. And as far as I can see, its connectivity's alright. So the only thing it can be is this 174 here. Hold it down. Flow one side. Just make sure how stable it is. And then we'll do the other one. Be careful not to touch the SIM slot. We'll be able to get some flux on there and flow that, because it's gone a bit weird around the side, but it'll look alright in a minute. So I scratched the little wire there, got some flux on there. You can see I've got a little bead of solder. The pad on this side's a little bit loose. So I've done the same on that side, scratched around it, got a little bit of solder. You can't quite see it, there's a ring of solder all around that wire there. But what I'm going to do now is stick a piece of kynar through here and just extend it over here a little bit, solder it down. I'm going to do the same on this side. The reason being is because this pad is barely hanging on. So I found two broken traces here. I don't know if you can see. It looks a bit blobby, the solder, but we've got one fixed wire coming up here to a wire there, and the other one goes to the resistor pack, one of the pins on the resistor pack there. Had to do that because the pad is broken on the top side. One of them is the wire. This wire that goes over here, there's no other way to do it because it's the wire underneath the IC. Now I could remove the IC and try and block the wire, you know, refill it and all that. It's just not worth it. It's far easier just to solder the wire on here. But right now I want to get the battery back on again, because this has been off here. You know, I thought I'd got all the connectivity there, put the battery on, tested it, no real-time clock detected. So yeah, I'm not really sure what happened. I'm suspecting that once that I fixed the one or two connections here, because that'll be three connections now around here, because the crystal wasn't connected on one side either to its cap. It's either the trim cap or the cap on the other underside there. That's where it gets fiddly on these, as well as there's lots of components on the underside, and you go through the wire, through a component on the other side, back to another wire, back up this side. It's really difficult to trace. I used a PCB board explorer. I'll post a link down below. That I found mega helpful around here. And I used it a little bit in this area around here as well. Anyway, we'll get the battery back on. Let's see if the real-time clock is now working. It'd be really good if it is. We've still got a weird audio issue with this, but anyway, let's one problem at a time. Oh, I'm not sure I want to work on one of these 4000s again. I'm not even sure I want to finish this one off, actually. 1 minute it says not detected, then it's detected. And obviously it goes crazy when it is detected. So I don't know what's going on there. I need to remove the battery again and check the connectivity again, but I can't see what's wrong. Maybe another trace has gone. Oh yes, the clock is working. I have spent ages, I kid you not, ages, absolutely ages. I think I spent most of Saturday, most of Sunday, and about 4 hours today trying to get this clock working. I've had it, you know, back reassembled and disassembled. The battery's been off and on, off and on, off and on about 5 times, I think, in total. Because each time I could have sworn everything was 100%. And the final problem was one side of the IC there, where the corrosion had got around it, it had got under the very end pin. It was pin 9, the latch pin. And it got under the pin. Someone had reflowed it. It looked okay, but the pin was not actually flowed, like I say, underneath. It had been lifted up by the corrosion, but it was flat and it looked soldered on. Connectivity wise, there was no connection to one of the ICs across the other side of the board where that latch signal comes from. So yeah, it took me ages to work that out because I kept measuring from the actual end of the pin. You know, instead of on the pin itself, I'll show you in a minute, just on the point where it joins the PCB, and there's a short there, there's a join, so you're like, well, that's connected, move on to the next pin. And it was only when I went on the actually tops of the pins on the actual chip itself that I realised there was no connection on the latch pin. That's the final issue. So we'll leave that now for, well, overnight. I've put a newish battery. I've not got any brand new CR2032s left. The battery that was on there was like 2.4 volts or something. I found one that's 3 volts. Just, you know, it should be a bit more than 3 volts if it's new, but it's around 3 volts. Fitted that. We'll just leave it overnight to see if that's okay. The interesting thing as well, can you see now it's actually working? It's got a different chip detected there. It's coming up with an MM something or other before. It's now saying an RP5C01, which is correct. That is what is on there. It was this side of this chip here. I reflowed this entirely, and that side there. This pin here, when you measured from the pin, you didn't have a connection, but when you did on the pad, and that's where I was measuring, on the very edge of the pad there, the bottom half of it, there was a short. So, you know, the real-time clock stuff looked okay, but only when you measured on the tops of the pins here after cleaning them, I realised there was no actual join. So it's like I say, it was the solder underneath that pin had all corroded, and the pin was kind of lifted off the trace, you know, so yeah, you had a connection on the trace, but not a connection on the pin. So I used Amiga PCB Explorer, as you can see here. I'll post a link down below. The website's just www.amigapcb.org. There are a number of different Amiga boards on there. There are a few different 4000 ones. In fact, there's 3 or so. This one's Rev B here. Now, I started with the schematics on the real-time clock and couldn't find the issue. And that's because some of the connections go all the way across the other side of the board. So, I mean, the one in particular I was having problems with was, let me look, was it that one? Yeah, it was, pin 9 on the 7474, just down here. And that was the latch. So, you know, following on here, you can see it goes to a via there. The via comes up under this chip here, goes to there. So I was able to test this connectivity from the end of the pad there. That was okay. What I didn't realise, as you saw a minute ago, it's on the pin here. On the pin was no connection. And it's because, like I say, the pin ended sort of, I don't know, 3/4 the way along that pad. And the solder underneath it was corroded. But anyway, and it goes right up to here on the other side of the board. And yeah, that was ultimately the problem with the real-time clock. So 24 hours later, we'll just test the real-time clock, but we've also got 2 new 4 meg, well, not new, but second-hand 4 meg modules that came from ST Freaks, these. So we'll just get these in there, we'll test the RAM as well. So we'll test the real-time clock first. Yep, there we go, still working, held the time and date from yesterday. So I'll just test that RAM, 16 meg fast. So I'll just let that go through a few passes and I'll report back in a minute. So as you can see, it's on its second pass there, so it looks like that RAM is good. So the next thing we're going to do is replace the 1 ohm resistor. This one's a bit smaller, it's an 0805 I think, but it should fit okay. So we'll remove this wire link, remove the resistor, replace that 1 ohm, and I'm going to replace the remaining caps on the other side of the board, and maybe get these ports off here and replace those as well. So there are many ways to get a component like this off. I think what I'm going to go with here, I'll just see if I can get the camera in the right orientation. I'm going to just heat both sides and with a big blob of solder on here and try and just slide it out if I can. It might be easier said than done. I might have to revert to hot air because the sides are not next to each other. There you go. Can you see it's tombstoned a little bit, but there you go. There's the component. Let's just stick that over there. We'll get a little bit of flux onto those 2 pads. Just absorb the solder from there if we can. That's one. You know, some people would just try and solder straight onto that now. You know, leave the solder there, maybe use hot air. You could do that. Certainly if you're using hot air to install it, there's no point in perhaps removing the solder, but that's the way I always like to do it. Get it nice and clean, and then the component goes on flat, and it's easy just to solder down with the soldering iron here. There we go. So if we just get one on there, lob it on. It's yeah, it's like I say, it's a little bit small. I've lost where it is now. It's over here somewhere. It's a little bit smaller, but it will fit fine. So yeah, the ones that are on there are not 0805s. That is for sure. like that. And if we get a bit of solder on this side. There we go, we just add a little bit of flux just because it'll just clean it up a little bit. And the flux just helps the thing level out a little bit. I'll remove the solder from the tip. If we just bob into that. Let's redo that one. And bob into there. Just redo the ones next to it as well, I think. Yeah, that'll do. But it is always worth just checking it to make sure it's not sort of shorted. There you go, 1 ohm. That's correct, 1.2 ohm. 1% tolerance on these. I've got a 1K next to it, and I think that's 400 and something, 750 for the audio circuit there. So yeah, that's all okay. That's that bit done. Let's move on to the remaining caps. So for the remaining caps here, I'm just going to fold up a little bit of foil here, and I'm going to captain tape this over there actually. Probably don't technically need to captain tape it down actually, but anyway, yeah, we'll do that because otherwise the foil might heat up. So if we just get a little bit of captain tape and try and stick it down kind of just at the bottom there. What I don't want is the heat going underneath the foil. Yeah, so it looks a mess, but it should do the drop job. Let's just wait for the hot air to reach temperature. I mean, technically you could leave these caps on here like this, because I'm sure lots of people are going to pipe up and go, oh my god, you removed those ideal you know, tantalums and ceramics and stuff and replace them with wet type electrolytics that may ultimately at some point leak. But the filtering characteristics are not exactly the same. The way they behave with temperature changes and things are not exactly the same. So, you know, and from a purist's perspective, lots of people actually want the boards to have the right, you know, the original components and things on there. So, I mean, I get that. Chris asked my opinion. My opinion was I would stick wet type electrolytics on it, if I'm honest. But there's probably very, very little difference. Good God, that's absorbing a lot of heat. I mean, it will do, because these are smoothing caps. You know, the rails they're connected to is the 5-volt rail and the ground rail. And I think these are multi-layer boards, like 4 or 6 layers, I think, probably. Certainly 4 layer. You've probably got like a ground layer somewhere in there and a 5-volt layer. There we go. So the same again, a bit of captain tape. It's not very well taped down, but you know what, I just need it just to protect the power connector here. I'm going to try and get a bit of leverage with that cap there, just try and pull it forwards towards me. I think what I might do is, because one side is molten, you know, one side's off, is just touch this side with a normal iron actually. There we go. Yeah, so I just freed it up a little bit just by touching it on that one side. Now, if the pads had been clean here, I wouldn't be removing the flux like this. But I could smell the electrolyte from the previous caps that were on there, not the ones from now, you know, that was removed, but the set that were original on there, the wet type. So, yeah, the clean-up work had not been thorough there for sure. Just carefully press it down and flow that one side. Just tap it, yeah, that's stable. Be careful not to touch the slot, any plastic parts. It's going to be quite fiddly for me to try and get this on camera after coming from this angle here. Just get a little bit of solder. Yeah, there we go, hopefully you can see that. I'll just try and come in from this angle here. That's it. Just need to get these last 2 off now. There's one here, you can't quite see, and one up there. You can see obviously stuck foil around there just because it's super close to the keyboard connector there. Whilst the keyboard connector's got a massive metal shield around it, I just don't want to risk melting anything around here if I can. These tend to come off pretty easy, these type. Can't get in there. Let's just use a little screwdriver just to get in between there like that. When it's loose, it will, there you go, it'll just wobble out of the way without issue. So the pads look alright there. Can I move that foil now? So the final one now is here, and there's nothing remotely plasticky around this area. The other thing with ceramic caps is they can oscillate, as far as I'm aware. I don't like to get stuck onto any wires or anything. No, that's alright, it's free. So I think we are nearly done. A friend helped me out with an 060 setup here on compact flash, as you can see. So I can't distribute the contents of that, but it has at least helped me test some games out, so I'll show you that in a minute. Now, the interesting thing is, all the games I've tested, the sound sounds normal, apart from June. At the start of June, where the wind sort of sample comes in, you know, it's a PCM sample, it doesn't sound right. It's kind of broken up and weird. Now, that kind of points to like an issue with Polar, or connectivity around Polar. Maybe it's got one data bit missing or something. But you know what? The fact that in all other aspects the sound sounds normal, well, apart from the frequency handling, I'll talk about that in a minute. Not really frequency handling, but responses and things. You can hear more of the low to mid, and the high is clearer, I would say, than on a 500. Now, from what I understand, there's an additional Butterworth filter or something, which is, yeah, I think there is, because there's like a second op amp. You've got like an op amp here, but then there's another op amp. So maybe that's what I'm hearing in terms of the difference, but that wouldn't explain the difference with June at the start of it, and we'll look at that in a minute. But the next thing I need to do is I'm going to get this board out. I'm going to swap these two ports around, because that mouse port, despite the fact, yeah, when you clean it you can get it working and it can be pretty reliable. You leave it for a few more days, it starts to corrode, and then you start to get problems again. You've got to move the port around like this, and then it's okay. I don't think it's anything to do with the connections and wires and things here, because all these little wires, I've not pointed out, but there's like a long strip of wires there. Those are all for the controls, actually, and you know, there was a little bit of corrosion there. So yeah, in some instances you could get bad controller points, and it could be those wires there, but I don't think that's it. I think it is all about the ports. These are really corroded, so I'll swap those out, because that's the last thing to do on the board. And I'm not sure if I mentioned it, but I might have done when I was recapping the electrolytics here. There's a cap missing there. Someone has removed that, or it's broken off or something. That should be there. That's the decoupling cap for the minus 5 volt regulator here, I think. So looking at the schematics, and it's 220 nanofarad. And if you think back, there was one over here, I think it was that one up there between these two electrolytics that was cracked. It had a crack through it, it was broken. So I replaced that. That's 220 nanofarads. It's exactly the same size as the other one, so I've got some of those, so we'll fit that as well. And I think that should conclude all of the work to this board here. It's just then testing and trying to make some headway, understanding of what's this issue with June at the beginning. Is it the fact that it's got an 060 and there's something in June that's not compatible with the 060? I don't know. Technically, I think if you're recapping this, you'd be better off fitting any damaged or replace ceramic caps before you fit the electrolytic in place, actually. But at the time I didn't realise the size, and I wasn't 100% sure whether there was supposed to be a component there or not, because on some of these Amiga boards you can see, there might be examples on here where you can see component pads but no component. I don't think there is, actually. I can't see one now, but I'm sure there probably will be, either on the top side or the bottom side. Certainly on the 1200s there are spots where components are not fitted, so let's just lob that down there. It's kind of tombstone, it's gone up on its side there, its edge. Hang on, just tilt it down and we'll just carefully position it. So I've got lots of solder on there, and I'll try and do the inside point first. I think what you can do is just heat and move and then just position it that way. There you go, it's pretty central. It's not going to be perfectly straight, but it isn't the end of the world. I just add a little bit of solder down this side here. That's it. So the other thing I'll do here is clean around Alice with the fiberglass pen, because the pins are just a little bit oxidised. There's no real corrosion, but here there is just like light surface corrosion. There's a bit of solder or something. I'll let someone touch that. I'm going to reflow around there, I think, because obviously that's Polar. And the sound issue we're having, you never know, maybe some pin somewhere around there that's not making a very good connection. So yeah, we'll get some... in fact, before we do that, let's use the fiberglass pen, because if we don't make sure that's super clean, it's not going to flow very well. It's difficult to try and get... It's difficult to try and get the tool into shot while I'm filming here without blocking the camera. So let's get a little bit of flux on there, and just for good measure, as I say, we'll reflow Paul. I'll do the other two sides in a minute. I'll do that off camera. These are the two that are the worst ones, really, you know, they're worst affected. So you do need a fair bit of heat with these PLCC versions here. You know, they absorb quite a bit of heat, I find. I'm not dragging across here, I'm just going to dab in and just leave them long enough because the solder is slightly corroded. I can always just do a bit of a drag reflow afterwards. And it's obviously very important you check you've not got any shorts there. There you go, so hopefully you can see how I've reflowed that. It's come out pretty well. This side here, there was a bit of a blob on one of the pins there, you know, so I've got it off with a solder braid. Yeah, it's not as clean and tidy as it could be, but it'll do. Yeah, so I'll have another clean round there in a minute, but anyway, that's that. So the next thing I'll do is get these off. I'm just going to use the solder pump to remove the solder on the underside. But ultimately, it's the pins themselves that you probably can't see from here, but they are pretty oxidised. There's green bits on them and everything. Despite the fact I've cleaned them, they're super unreliable. Well, the mouse one is. So let's get that off. So because I've already had new solder on here, I don't need to add any additional solder and flux. You know, there's still lots of flux. Can you see that the pins freed up straight away on that one? It's the anchor points that are going to need a bit more heat and stuff on the sides. But I think these will be easy to remove just with a solder pump here. One thing I will point out, I prefer the original sockets to the modern replacement ones you get. The ones from like Amiga kit that I've ordered for this, yeah, they're functional, but they're not the same. I'll perhaps show you why in a minute. Well, I'm guessing it's the same one that I've had on a 500, where there's when you take the nuts off, the front part of the plate comes off entirely, which is not the same way these original ones were designed. And this is the bit I've been dreading, and you know what, it has been just as painful as I anticipated it would be. Yeah, you're not going to be able to see much for the tool here. I'm just like pushing up a little bit to get it away from the edge, both irons. Yeah, and then trying to remove the solder, but it's not all coming off. Let's try it, doing it opposite way around. You can see the bottom half's done. Very difficult because of the clearance, because there's SMD components as well. Yeah, most of that's off. You've seen this technique before, but you know, a little grip and pivots, 2 or 3 pins at once on here, very gently. You don't want to damage the surface of the PCB, and if they're not totally freed up, they won't move. But as you can see, I think all of those, there you go, that's moving now as well, I think. Yeah, all of those I think are freed up. You can obviously pinch these this way, can you see that? They're moving and they're moving. So I think we're nearly there. From the top side you can see it's moving freely. It's just caught on the anchor points and stuff. The worry with this is if something's not freed up on this side. I mean, I think it has, because it's really loose there. But yeah, there is a chance. Let's see if we can just get a little bit of a... But there is a chance you could damage something if you're not careful. They do not like removing these. You could probably try and twist them a little bit to the sides like that, because then they're kind of like more in the centre, you know, as you twist them sideways like that, they kind of like go into the centre more. There we go, it's starting to come out. There we go, I just gave it a gentle lever on either side so you can see that's come out. You can have a bit of a better look at that now. Yeah, hopefully you can see inside there. I mean, it's not too bad, but it was making an awful connection. It really was. You know, you can see the greenness on some of the pins there. So anyway, that's that. So I'll clean up around here with cotton bud, an IPA and a fiberglass pen, and then we'll just get the new socket on there. So there's our new socket. Yeah, the problem with these ones, and these came from Amiga kit, is when you remove the nuts here, this metal piece comes off and you just have the black plastic there with all the pins stuck out. So yeah, when you put it back on, you've got to make sure that the D is totally correctly aligned, because you can get it sort of like skewed to the sides, if you see what I mean. Anyway, I'm not going to take that off because it is nice and straightly aligned. We'll just carefully get this back on there if we can. Hopefully everything's going to go in. There we go. Lovely. Is that protruding more than this one? No, it's not. It's kind of in line with the board. That's okay. So I just need to flip it over and solder it on. Now what I would do here is do the anchor points first, actually. Do make sure it's totally straight and aligned, and solder the anchor points. Then just inspect it to make sure it is nice and straight. I'm going to need to use both irons to do this, but anyway, that's enough for me to just get some solder there to hold it. Tidy that up in a sec, and we'll do the same thing over this side here. It's going to look a mess, like I say, until I can reflow with both irons at the same time, because there's just not enough heat. And then just inspect it kind of like that to make sure it's okay. Also make sure it's not protruding too much, you know, it's kind of like right on the very edge here, but there's a gap on the side of the case for these ports there, so I don't know if you can see, it's like 0.5 millimetre further down. That's one of the problems you can have with replacement types of connectors, but it's very close. I think that'll be okay. So I'll just solder the other points there, and then I'll just reflow the anchor points in a minute with more heat and a bit of flux. Yeah, there's number 2 off. So same thing, I'll clean up with a little bit of IPA to start with. There's not much corrosion around this one, but if I'm going to replace one, I may as well replace them both. They'll be consistent then. And the hex nuts were missing off this port here as well, so, or one of them was. I think there were only one out of the 2 ports. There was only one nut. So I'm not sure where the nuts went. So I'll probably use my little metal scratchy tool here, because as you can see, even with the fiberglass brush here, the pads are not coming up very well. There we go, that's not too bad. Get the new port on. So there we go, that's both ports replaced. Now I have to admit, that for me was the worst bit, and it's the reason I left it to last. Finish with the bits I actually hate. Sometimes I like to get the worst bits out of the way first, but when it comes to these ports, I never enjoy it, because there's always that risk that some of the pads could come up and stuff, and it can be quite difficult sometimes getting the anchor points to free up, as it was with this. So I'll use cotton buds initially. I need to reflow 1 or 2 of these little SMD components here, and we need to clean them up because they're just a bit awful. You know, corrosion's got kind of on the underside a little bit, but we'll brush this area as well once I've got the majority of the flux off this way. So these 2 sims that don't work, I'm going to give them another clean, maybe even reflow these with some flux into solder braid. That was looking very clean the other day, and it seems to have oxidised again. You can see I've written on there int. This one was intermittent, so you know it would pass for I don't know, 1 or 2, and then it would fail. Whereas this one fails every single time as soon as it gets to a specific address. But it's the same here. Can you see this? This side looks relatively clean, not so much over here. So we'll have a go with some vinegar first, I think. And I'll get the fiberglass brush back onto there. I'm going to inspect the actual pins on the chips themselves as well, just to make sure no corrosion's got onto the board there. It does seem to be localised, but it could be affecting the bottom parts of those ICs there. So I'll show you the edges on them in a minute, but that's been cleaned up super clean now. And it's doing the same thing, it's intermittent. It passed 4 times there and then failed. Whilst that's booting, I'll show you the pins on this one. Can you see? Super silvery on both sides. So it's not like we've got a bad connection there. Not at all. And the sims themselves, you know, the memory modules on them, look fine. You saw the same fault there in the previous video, bits 1 and 2. So that's alright, it just gives me some confidence that it is not the pins on these, there are actual faults on them. And just to show you the pins on that one, yeah, you know, they're not brilliant. You know, if you get the right light, you can see they're a bit worn, but there is no corrosion on there. The pins down this end may be a little bit dirty still, but it's been thoroughly cleaned with a fiberglass pen. We've used vinegar and IPA and stuff. I mean, it could be one of the little, can you see there's like a little hole, you know, there's a through hole in every single one of those. Maybe one of those is faulty. So I could try just getting a bit of flux on and tin these up. I might just do that next. But I don't think that's going to solve it. I think this one's intermittent, you know, because this passes a number of times, this one. It went around about 4 or 5 times with Dennett errors. If it was a via, yeah, it wouldn't do that. It might do, you know, if you power cycled it, you'd expect it to be faulty straight away, and it doesn't. You can run several cycles or more before failing. The one thing I will show you on the other 2 modules here, you can see this one, and I haven't done this, somebody, when they previously cleaned this up, have scraped off the gold plating there in a few places. You know, it doesn't look great, that one, does it? Look at the underside of here. Again, it was like that before I got to it. You know, the edges have gone with corrosion. Corrosion's actually eaten the edges off, but this one works. Gold plated, that one, and the other gold plated one. This needs another clean because I didn't thoroughly clean this one, but this one is working as well. You can see a green via there. So yeah, I'll just give these another quick clean, but these 2, bank 0 and bank 3, are the ones that are okay. Before I clean those up, something else I'll point out, these are 72 pin sims, can you see there, 72. So yeah, they can be quite hard to get hold of. Lots of PC motherboards did use them, but they're in short supply these days. It's the same with 30 pin sims, although from my experience you seem to be able to find more 30 pin modules than you do the 72 pin ones these days. You can see down here there's a jumper. It says on the top there, top position, 256K times 32. The bottom position is 1 meg times 32. That might confuse you. You might think, well, so I'm choosing between 256K sims and 1 meg sims. How does that work? But it's times 32. It's 32 bits. So in terms of actual size, you've got to multiply the size on the left there, 256 or 1 meg, by 4, because you've got 4 bytes in 32 bits there. Does that make sense? So actually, in terms of sims, you know, you install in either 1 meg sims or 4 meg sims, let's say multiply by 4 to take into account 32 bits. The other thing I've always thought was a little bit crazy with that is, and it's not really crazy, it just is in a sort of psychological sort of way, that when you come to these newer machines, you know, that had 1 meg, 2 meg, 4 meg of RAM, etc., you think, wow, that's tons of RAM, you know, so much space, you know, if you've got like 16 meg on here, that's like a crazy amount of RAM. One thing you've got to think of is it's got a 32-bit processor. So an instruction could be as many as 32 bits. You know, it's going to be a D word. You know, you've got a byte. 2 bytes makes a word. You know, 16-bit word. So the 16-bit systems had, you know, there's two bytes down the data bus, 16-bit wide data bus. But on a 32-bit system like this, you've got 4 bytes. So you haven't got as much space as you actually think you have in terms of code. You know, if you had 1 meg on a system like this, for example, you've got to divide that by 4 in terms of what the CPU instructions would take up, you know, in terms of 32-bit wide instructions and things within that RAM. So, you know, I don't know, a 1 meg system, well, actually, you've kind of got 256K, if you think about it, 256, you know, thousand addresses, not the 1 meg that you think you've got. Because, like I say, it's divided by, you know, it's divided by 4, effectively, because you've got 32 bits. I mean, technically, that's not entirely true, because if you look at the graphics modes on a lot of these things, they use like a byte per pixel, or less than a byte per pixel. So in terms of the graphics, you know, assets, sound, you know, this 8-bit sound comes from Paul on a machine like this. So yeah, in terms of your assets, your graphics, your audio, things like that, yeah, you're kind of making as much, you're making use in terms of a byte, you know, individual byte level. But when it comes to CPU instructions, code is taking 4 times the amount of space it would on an 8-bit system. But I always thought that was a bit strange. It can confuse you a little bit, and you can actually think you've got more space than you actually have, really. If you've got tons of code in that RAM, it's going to eat up more space than you think it is doing. And while I'm reinstalling these, I just thought I'd show you something. The reason these were removed before transit, can you see this? Look, they just fall out. You push it down like that, Now on good, decent, brand new sockets, when you push fairly hard there, you'd expect these side bits to clip out. What you've got to do on this is just watch this, I'll show you. Just get it in position, push it down. It's not clipping, look. So just very carefully put a little bit of pressure here. Did you see that click? It's snapped over the edge. You could also just, as you hold it, just push that in a little bit like that, very gently. You don't want to snap them off. This plastic is super brittle, but that's supported on that side. It's just a case of doing the same on the other side. Press it down. There, it's clipped on the other side now. But you do need to press these down until the wings kind of clip in. Otherwise, they will fly out. So the memory's testing all right. Obviously, they've still got those 2 faulty sims. I think what we'll do next is just carefully, if we can, open up this here, Superbuster 390539-11. So this is the preferable Rev 11 Superbuster. I think it fixes a couple of minor bugs and gives some better performance. I think you get a better throughput. I think it relates to the burst mode or DMA side of things. I can't quite remember. I'm sure someone will post down in the comments below. Anyway, let's just put that there a sec. So we'll remove this Rev 9 one. Now, I am not sure about the best way to approach this. I might inspect the underneath of the board to see if there's any way to get the chip out from the underside. I don't know if this is going to work because it's a low profile socket. I have no... So I did just have a go and slipped off. So I don't know. Yeah, you see, it's come out there, look. Yeah, you can see I scratched it twice there, just gently on the top, but it has come out. I'm not bending it there. There we go. These low profile sockets are much harder to use. And just for the record, I am not lavering it here. I'm just trying to get under it because, like I say, it's out. It's already out. But don't use a screwdriver to lever. There we go. So yeah, I'm sorry for making a couple of little marks on the top there, but that chip is okay. The pins look a little bit oxidised. Oh, there's a little bit of corrosion around there. Can you see that? Yeah, you can just see some furriness around the pins there. I mean, it's probably done no damage, but we need to clean around that before we fit this other Superbuster, I think. I hope we've not damaged that by removing the chip, because we could have done. There was some corrosion in there. I'm going to go get the toothbrush actually, because this cotton bud is not going to do the job, I don't think. I can't get right in there. Yeah, so let's just have a little brush around here. I hope this doesn't now create a new fault. I would hate to have to replace that socket. It's surface mounted. It's a bit fiddly. You can just literally sit it on there once you've got the new socket and then drag the solder. But nevertheless, I'd rather try and avoid that if I can. Can you see there's a spot repair being done down here? There's a little wire here and another wire here going from a wire to one of the pins. So there must have been some corrosion here. Someone has obviously dealt with that a little bit. The pins, yeah, they're not bad. They're not bad. So I'm about to stick this back in. Let's just move it out of the way a minute, because what I'd like to do is just power this up without a buster and see what happens. Yeah, so without a Superbuster you get a yellow screen. Well, I did have a yellow screen and then it seems to have rebooted again. Let's just try that again. So it's a good test because I'd like to just see how it behaves. So I'd like to see how it behaves, look, without the IC. So we'll get the new one in there. I'll switch it off first, obviously. So I've got my ESD wrist strap on here. So here's the new one. We've got the shaved off edge there, so that corresponds with that there. Carefully get it lined up. I think that's okay, and then press it down. Yeah, it makes a good fit. So let's try that. It's not booting, is it? That's a little bit concerning. It is not booting from hard disk with that Superbuster. Yeah, it's not looking at the hard disk at all. Well, this is super annoying because it's now not booting, and it's going to be a connection around here. Just as a consequence of removing that chip, you can see here the LED there is not flashing. That should flash super quick after power on. So I mean, I could try just pressing a little bit, see if anything happens. I don't think so. I think we've got a bad connection around that. I've cleaned the chip up, by the way. That's not made a difference. I just hope nothing's faulty here. got to be a bad solder point there. That chip is in. It's in as far as it'll go. Nothing, nada. So I'm going to have to get it back onto the mat, and I'm going to have to get some flux in there and reflow the connections in there. So sorry we've had to abruptly end the video there. There is a third part which will follow soon after. It'll go up for my Patreons first. If you'd like to support by Patreon, please see the link down below. Please like, share, subscribe, and I'll catch you in the next video.